Hello viewers, welcome to this tutorial on Arduino Mega Board programming and simulation. So in this tutorial, I will be discussing about switch activated LED. So what we are going to do in this tutorial in the sense, we are going to interface a switch to an Arduino Mega Board and also an LED to an Arduino Mega Board. So by activating the switch, the status of the switch will be displayed in the LED. So that is what we are going to do in this tutorial. So we are going to use Arduino IDE for writing our embedded C program, and to check the logic of the program we are going to use a Proteus 8 simulator. So first let us discuss about the hardware part. So we are going to have an Arduino Mega Board which contains Atmega 2560 microcontroller. So I am going to take a push button and I am going to connect it to the pin number 11 of your Arduino Mega Board. And I am going to take a LED which is a two-terminal device with anode and cathode, and I am going to connect the anode to the pin number 7 of your Arduino Mega Board. Cathode will be connected to the ground. So by activating this switch, the status of the switch will be displayed in the LED. So that will be the objective of our program. So now let us dive into our hardware circuit. We will try to first develop our circuit in Proteus environment. Then we will try to write a code in Arduino IDE, convert that high-level language code into a hexadecimal file, then import that hexadecimal file onto your Proteus simulating environment. Then we try to check the logic of our program by executing the code. So first, in a Proteus environment, I am going to create a new project. Here I select the folder where I want to create a new project. After selecting the folder, I try to give a name for that project. So I will give it as switch LED. And the project should have an extension of .pdsprj. Then press next. First I need to select a template where I need to draw our circuit. So I am going to select a schematic which is default size. You can also select some other sizes like A0, A1 in portrait form as well as in a landscape mode. After selecting the schematic, I will press next. We are not going to create any PCB layout, so I am going to leave it as it is, and also I am not going to use any firmware. So I will leave it as it is. Press next. Once you do that, you will find that only schematic is selected, other layout and firmware are not selected. Press finish. So it will open this schematic window. In this schematic window, we need to select first the components. In order to select the components, I go to this icon P for pick devices. Here I press pick devices. In this keyword, I am going to type Arduino. So when I type Arduino, you will find different versions of Arduino which is supported by Proteus will be displayed here. So I am going to select Arduino Mega 2560. Here you can see the board layout, and when I double click on this, you will see that this item will be included in our pick devices. So once I click this, it will get included. Next thing which I require is an LED. So I will type LED, and I am going to select an animated version of an LED. So here you can see different animated versions. I am going to select a blue LED animated version. So double click on it, it will get added to the pick devices. Next thing which I require is a push button switch. So I type push button. When I type push button, you can find SPST type of push button. Double click on it, it will get added to your circuit. So these are the components which I require right now for building the circuit. So once you have selected the components, I can press OK to come out of the tab. So now we are going to build our circuit in this schematic. So first I am going to select the Arduino Mega Board. Click on the Arduino Mega Board. It will show the board here, and you go to your schematic window. Wherever you want, you click on it, and you can place it wherever you want. So I am going to place it at the center of my schematic, and as I told earlier, we are going to connect a switch to the pin number 11. So I select a push button and I put it here, push button, and I connect one end of the push button to pin number 11. So other end I am going to connect it to the power supply. So in order to select the power supply, you go to the left side. Here I have a terminals mode. In terminals mode, you select the power and you can put the power here. So connect this power supply to the push button. So right now I have connected the switch to pin number 11, but this will not help us because by default the GPIO pins will be in a high impedance state. When I press the switch, what will happen? The pin number 11 will go from high impedance state to logic 1. So that is not desirable. So ultimately our pin number 11, it should go from logic 0 to logic 1. So in order to do that, I am going to select a resistor. So go to components mode. I am going to select a resistor in the PIC devices. So I select a resistor into our project. So now I am going to use this resistor in a tilted mode. So I am just going to rotate it using the buttons available on the left side. Then I am going to put it here in my circuit and connect one end of the resistor to the switch one end, and another end I need to connect it to the ground. So again I go to the terminals mode, I select ground and I place it in the schematic window, then connect the other end of the resistor to the ground. So now what happens, since this resistor is connected to ground, by default this pin number 11 will be at logic 0 volt. Whenever I press a switch, it will go from 0 to 5 volt. Then I can easily use this logic for putting the status onto a LED. So this modification in circuit is required. Otherwise what happens, by default the pin will be at high impedance state. It will go from high impedance state to the logic 1. So that is not desirable. So we want the pin to go from 0 to 5. So that can be achieved using a resistor connected to the push button. So next thing what I am going to do is I need to connect an LED to the pin number 7. So for that again I go to the components mode, I select LED, blue LED. So I want to connect this LED to a pin number 7. I go to location in the schematic, place it there, and I am going to connect the anode of my LED to pin number 7. And cathode I need to connect it to ground. So in order for connecting ground, again I go to the terminals mode, select the ground, put it into your schematic. Then I connect this ground to the cathode of your LED. So we are done with our circuit. So we have connected a push button to pin number 11 and also we have connected an LED to your pin number 7. So let us save this project. So I am going to save this project as switch LED. So once I have done, we need to work on our embedded C program. So I go to Arduino. So in Arduino, when you open, you will get by default void setup function and a void loop function. So here I have written a code for a switch activated LED. So as we have defined our hardware, the push button is at pin number 11. So we define a variable int, and that integer variable is assigned with the value of 11. Same way, another variable is defined, LED, and this is assigned with the value of 7. So this push button variable represents pin number 11 and LED variable represents pin number 7. So first thing in our programming is we need to set the pin as an input pin or an output pin. So in case of push button, it is an input pin. For a LED, it will be an output pin. So that is defined by this pin mode. So pin mode is a function where we are going to configure our pin either in an input pin or an output pin. So I define push button, which is nothing but pin number 11, and I am setting it as input pin. Same way again I am going to use pin mode. So in pin mode I am defining the pin number 7 and we are trying to define it as output pin. So once our pin configuration is over, we can define the logic. So the logic is defined in your loop function. So as we all know that loop function executes infinite number of times. So this code continuously runs for infinite number of times. So in order to read the status of the push button, I am going to use a function called as digital read. So digital read from pin number 11. So that digital read will give me either a 0 or 1. So this value will go to a variable called as button state, which is defined as integer. So then this button state is lit to your LED with the help of a digital write function. So digital write, I give the pin number of LED, and what should be the value of this LED? It depends upon the button state. If the switch is pressed, LED will be 1. If the switch is not pressed, LED will be 0. Then we need to retain this value for some time. So in order to do that, we put a delay function for 100 milliseconds. So this code is going to continuously run. So as I press the push button, what happens? Automatically the status of the push button is displayed in your LED. So now we have been done with our code. So we need to save this code. So I am going to save this code in a location. So I am going to go to again downloads. In downloads, work Arduino environment. So here I am going to define this program LED push button 1 dot C. So we need to save the program with an extension of .c. So once this is done, I need to convert this high level language program into a binary file or a hexadecimal file. In order to do that, I go to sketch, export compiled binary. When I give this export compiled binary, this embedded C program will be converted into a hexadecimal file. So that we can visualize in the folder. So here you can go to this, you can see LED push button, there is a hexadecimal file. So if I open this hexadecimal file using a notepad, you can find this is the opcode. So this opcode only we are trying to import into your program memory of microcontroller. So this is the program which is going to enter into the Atmega 2560 microcontroller. So once this is done, we again go to our Proteus environment. Now our hardware is ready, our program is ready. We need to import that program into the program memory of your Arduino Mega Board. So for doing that, I right click on this, edit properties, then select the program file. So program file is nothing but the hexadecimal file. So I go to that location, select the hexadecimal file. So you can see X file. I am trying to import it into our program. Press OK. Then I am going to execute this circuit and see whether our programming is working properly or not. So in order to do execution, I go to this play button in the Proteus. When I press this, right now the push button is in off state. So 0 volt is available in this pin. So you can see it using a blue LED. So blue means 0. If it is red, you can see here, red means it is supply, 5 volt supply. So when I press the switch, you can see the pin has changed to red color and the LED starts glowing. So until I release the switch, the LED will glow. If I release the switch, you can see the LED goes to an off state. So that is how we can put the status of a push button in LED. So once we have checked the logic, we have done with our code, we need to stop the simulation. In order to stop the simulation, I am going to press stop button. Then save the project. So in this tutorial, I have discussed about this switch activated LED. So in the next tutorial, I will discuss about another version of program to do the same task. Thank you for watching. Please subscribe for more technical learning. Thank you.